Welcome back to another exciting adventure of the Aetherband channel. I'm your host, Travis Finley. I chuckled to myself because I have that introduction for another channel and I was almost going to say that other channel's name. Okay, so welcome back. As I said, please make sure, if you haven't done this already, to subscribe, like, and share. Hitting those thumbs up helps the algorithms to send this out to a broader audience, so that would be very helpful for this channel, as well as you're sharing this with others who might find an interest in this discussion. Again, I am a layman, but I have a vested interest in this topic. I am invested 110%. My responses, my reactions are going to be from the hip, and if there is anything that I say that is incorrect, then take that with a grain of salt as part of the learning curve. But if you happen to notice that I've said something incorrect, or if you want to address anything, please make sure you look in the description box below for my email address. And let's get jumping into optics for beginners. Going to try to keep these as short as possible, just so that they are easy to watch. You don't have to sit down for a long period of time. However, there are going to be some lengthy videos as well. So here we go. Optics is the science of light. If you know nothing about optics, this page will explain the basic facts needed to understand how mirages and other refraction phenomena work. Okay. Optics is divided into two main areas. Geometrical optics. Okay, geometry has to do with the shape of, or the measurement of land, right? Geometry, geometrics. Geometrical optics, which deals with how light moves and where it goes. I don't know. I'm not sure how geometrical optics works with that, but whatever. And then physical optics, which deals with the nature of light itself and with the interaction between light and matter. There are several related fields like vision and the science of color. One of these related fields. One of these is atmospheric optics. Okay, atmospheric optics, as we talked about in the very first video, is my concept of the Aetherband. Okay, everything that's atmospheric optics is the Aetherband. And I saved 3 syllables. All right, which deals with how light interacts with our atmosphere. Two kinds of optical phenomena are involved in green flashes and mirages. Okay, there's atmospheric refraction and atmospheric transmission. Okay. Refraction belongs to geometrical optics, and transmission belongs to the physical optics. Geometrical geometrical optics, reversibility. People often talk about a line of sight between 2 points. Here are 2 observers, observer A and observer B. If A can see B, then B can see A along the same line of sight, but in the opposite direction. B sees A sees B. Okay? Rectilinear propagation. Rectilinear propagation. I drew a straight line, he says, I drew a straight line between A and B in the drawing above, and people usually think of lines of sight as being straight lines. That's because they are. A basic idea behind geometrical optics is that light travels in straight lines. And as I said in the first episode, and I'll say it again and again, I am challenging the status quo on this science. But there's a catch to this statement. Of course there is, because in pseudoscience, you gotta qualify everything, because you will eventually contradict yourself and then you'll have to make a caveat. All right? Light only travels in straight lines in a perfectly uniform medium. All right? And as we know from the previous reading on Andrew Thomas Young, air is not a homogeneous medium. It is not perfectly uniform. So there is absolutely no way for us to know if there is any other way that light travels except in making observations in the real world. Okay. But light only travels in straight lines in a vacuum. Okay? The only place a vacuum exists is in the mind. We do not have vacuums on Earth. Vacuums on Earth are not natural phenomena. Space is a creation of the mind. It's a conceptual environment, and that is what the vacuum is. Okay, so here we go. And this is an interesting caveat here that he says. Light travels in straight lines, but there's a catch, because light only does so in a perfectly uniform medium like a vacuum. But real, okay, that means that a vacuum's not real. Okay, don't miss this sleight of hand. Okay, but real transparent materials such as air, water, and glass always have small internal variations in their optical properties that bend, well, I'm going to say distort, okay, because it's a three-dimensional bend. It goes everywhere. Okay, you cannot, I can show you a video of a distant observation where the fold line of the mirage completely gets enveloped and you lose the whole thing. So it's like all points get swallowed into itself. So there's no going up, down. It's not just going up and down. It's going every direction. Every direction, okay? So, so light doesn't quite travel in straight lines in real materials or in the real world, okay? Particularly, light does not travel in straight lines in air because air isn't uniform. There we go. Air is not uniform. Its density varies from place to place, especially at different heights. The variations in density with height are very important in atmospheric refraction because they make light travel along curved paths, not straight lines. This is the point of contention. Show me that you can trace. Show me that you can observe a curved path. Don't tell me when you look at a picture, don't tell me that the path is curving there because I don't see it. Where? Show me. Right? Okay. Rays and beams. There is another catch. There's another catch to the straight line statement. So we'll call this the straight lines fallacy. Okay? Straight lines fallacy. Lines are a geometric idea. Lines are points. Lines, points or lines are a geometric idealization. They have no width. Okay, so they're not three-dimensional. These straight or curved lines along which light moves are usually called rays in optics. Like the lines of geometry, they are a convenient fiction. Listen to what is being told you. Rays are fiction. Vacuum, not real. Fiction. There really is no such thing as a vacuum. Fiction. There really is no such thing as a ray of light. Fiction. Instead, what exists in the real world is changing the word ray to beam. That's all he's doing. That's all he's doing. What exists in the real world is a beam of light. And beams have width. Okay, so again, show me this. Okay, height, width, depth, three-dimensional. Okay, fine. Right away, I should caution you that what I call a beam of light is not what you might call a beam of light. You probably think of something like a searchlight beam, all lit up and plainly visible. But that searchlight beam is only visible because of light that is scattered out of the actual beam. Show me what you mean by that. Okay, are you talking about ambient light? Because at what point... Okay, look. The searchlight beam is only visible because of the scattered light out of the actual beam. So if you see a beam of light from a searchlight beam, within that image, there is a smaller beam out of which the light that you do see, it's like the sun glare, I suppose, right? When we look at the sun, we see a glare, when we look at the sun, we see a particular shape. But if we put on a solar filter, we see that the sun inside that is actually smaller than the glare that we see with our naked eye. So that is, to me, what he's talking about here. If I'm incorrect, then, you know, whatever. So what you see is not the beam itself, but the path of the beam, made visible by light that is being scattered out of it towards your eye. If the beam were traveling through a vacuum instead of through polluted urban air, it would be quite invisible. Again, you can't ever show me this. You can show it to me with other spectra, right? Other light spectra, sure. But that we're not talking about spotlights or, you know, whatever. Like we don't ever see daylight in rays or beams unless there's an obstruction. Okay, so let me show you what I mean. All right, here we are. We are underwater, and we see a dark band here, a lighter band here, a dark band here, and then a variation of light bands all the way across. When we see a dark section like this, that means that the water up here is condensed enough, or the angle is such that it is too thick for the light to get through. So here you have a sunbeam or a sun ray. I wouldn't really care which one you call it. Okay, the only reason why we're seeing these lines is because up here the water is dynamic and moving. So if this were a video, this whole scene would be dancing around because the water up top is dynamic. Okay, does that make sense? This is no different than looking at a tree line with shadows on it. Okay? All right, so this is just like the underwater. And these trees are just like the water that is too dense for the light to get through. The only reason why you see these rays is because there is a division in the path of the light. Okay? So call those sunbeam. Now, the thing that's different between the water you could actually trace the line, right? Whereas all we're seeing now is the reflection of the light off the snow, but the concept is still the same. Okay? All right. Now, what's the relation between rays and beams? Well, beams are real and rays are something we imagine. But again, he hasn't proven this. Okay? We're reading this. He hasn't proven anything. He didn't give any citation to what exists in the real world is a beam of light. This is all rhetoric. All of this is just rhetoric, okay? Beams are real. Rays are something that we imagine. You can think of a ray as the center line of a narrow beam. That has no meaning. If a ray doesn't exist, there is no center line. But the way that this sounds to me is almost as if this is like a fiber optic cable. The beam is the cable made up of smaller rays within it. So each of the smaller fiber optics in the cable are the rays, but those fiber optics are real. So this makes no sense, Andrew Thomas Young. It doesn't make any sense. All right. As Mascart says at the preface of his great textbook on optics, a textbook which I have and I've started to read, but it's pretty dense. Mascart says, a first glance seems to show that in a homogeneous medium, light is propagated in straight lines. Okay, I know that this is a reference to an older work, but where has this been done? Where have you seen light propagating in a straight line in a homogeneous medium? Where do you see that? Okay. And that the direction of these rays changes suddenly according to determinate laws at the surface of separation of two different media. All right? We're talking about right now the old pencil bending in the, refracting in the water trick. Okay? We don't look through two different media. Do you understand that? Looking through the atmosphere across the water into the distance is not like looking down into the water at a trout and trying to throw a spear at it. That is not what we're doing. So it seems to me that there's a conflation of these ideas. They just try to, because I think they cannot manipulate these claims, then they just it's just word salad. It's just rhetoric. From this point of view, one can build a special science. A special science. That's called pseudoscience. One can build a special science in which one extracts from simple questions of analysis the study of bundles of rays originally emanating from a single source. However, experiment easily shows that the ray of light has no physical existence. Okay, so experiment, that reference means that someone has manipulated something, but there's no citation. Just saying. And that the ray of light vanishes as if one tries to and that the ray of light vanishes if one tries to isolate it. It is impossible to know the real properties of bundles of rays and the images they produce in optical systems without introducing the dimensions of apertures by which they are limited. Okay, so here, I'm going to change some words around here. Okay, you ready? Let's do this. However, and again, I'm paraphrasing, observation easily shows that unicorns have no physical existence, and the unicorn vanishes if one tries to observe it. It is impossible to know the real properties of the herds of unicorns and of the magic poop they produce, right? Okay, so these rays of light, this is all talking about La La Land. This is all made up. This stuff is made up. Unicorns have no physical existence, and you can never see them because they always disappear when you try to isolate it and take a picture. They always just go poof, and they're gone, right?
And like that, he's gone.
Really, there is no such thing as a unicorn. They are a convenient fiction. All right. So again, I'm just talking through this stuff, trying to lay the groundwork for discussing this with others. Please make sure that you subscribe, like, and share if you have not done so already. This has been another exciting adventure of the Aetherband channel. I'm your host, Travis Finley. Until next time.